Good morning, students. Now we will discuss about Schering Bridge. Simply, it is the existence of Schering Bridge. Now we will represent different component names here. Just here, I'm assuming it is the first term, second term, third term, fourth term. So in the first term, capacitor is there. So I'm representing here C1, capacitor 1, and resistor R1. It is second arm, resistor R2. It is the third arm capacitor. So C3, capacitor in third arm. It is unknown. So Rx, and it is unknown Cx. Simply, this sharing bridge is used to measure the unknown value of capacitance. To measure the unknown value of capacitance, the sharing bridge is used. Here, these are the different arms we're having. And just I'm representing the terminals here like A, B, A, B, C, D, as you wish. Just represent the terminals as you wish. And the construction point of view between the terminals A and C, we're having the parallel combination of R1, C1. Between the terminals B and C, we're having resistance R2. Between the terminals A and D, we're having capacitance C3. Between the terminals B and T, we're having Rx and Lx. Between the terminals A and B, detector. Between the terminals C and D, source, voltage source. It is a construction. Now we'll write here the impedances of these arms. Look at here from the bridge circuit. From the bridge circuit, first term we're having here the parallel combination of C1 and R1. So I'm writing here admittance Y1 5 whenever we're having the parallel combination, better to write here the admittance. So Y1 equal to 1 by R1 plus j omega C1. That is the equivalent impedance in the first term. And while coming to the second arm, we're having R2. So only resistor Z2 equal to R2. From the third arm, we're having the capacitor. Only capacitor C3 is there. So from the third arm, we can represent here Z3 equal to minus J by omega C3. From the fourth term, we're having R and C series combination. So just Z4 equal to R x minus J by omega Cx. It is the impedances from the forearms. Now, in case of AC bridges, the bridge balancing condition, the opposite impedances, the product of opposite impedances is equal to product of another two opposite impedances. Here it is the first arm, it is the fourth arm. Just assume like that. So we know that we know that the bridge balancing condition is Z1 Z4 equal to Z2 Z3. Here Z4 is nothing but Zx. So Z1 Zx equal to Z2 Z3. And look at here Z1. Here we're having Y1. We're not having Z1. So convert this Z1 into Y1. So simply Zx equal to Z2 Z3 by Z1. Here 1 by Z1 means Y1. So we can write here Z2 Z3 Y1. Y1. Then Zx equal to Z2 Z3 Y1. Now look at here. Zx or Z4 equal to, here it is the Zx or Z4 equal to Rx. Z2 value is there, Z3 value is there, Y1 value is there. Just substitute all those values. So here Zx equal to Z2 means, first Zx means Rx minus J by omega Cx. So Zx means here Rx minus J by omega Cx equal to Z2 means R2. R2 Z3 means minus J by omega C3 minus J by omega C3 into Y1 means 1 by R1 plus J omega C1. 1 by R1 plus J omega C1. These are the substitutions like this. Now just simply we have to multiply and simplify and compare real and imaginary parts. Just LHS as usual. Rx minus J by omega Cx equal to this one into this one. So minus J R2 by omega C3 into the same thing. 1 by R1 plus J omega C1. Now I am multiplying this term with this and with this. So this as usual, Rx minus J by omega Cx equal to this one into this one. So minus J R2 by omega C3 R1. Next this one into this one. Minus into plus minus J into J, J square R2 omega C1 is here by omega C3 is here. Now here the value of J square is nothing but minus 1. So minus 1 into minus plus, and at the same time omega get cancelled. So Rx minus J by omega Cx equal to minus JR2 by omega C3 R1 minus into minus plus R2, here it is R2 C1 R2 C1 by C3, the remaining term. So now compare real part. Compare real part. Here the real part is nothing but this one and this one. So Rx equal to R2 C1 by C3. That is the real part. Real part. Rx equal to R2 C1 by C3. And similarly, we have to compare imaginary part. Compare imaginary part. Here the imaginary part is at this side this one, at this side this one. So I'm equating those two. Minus J omega Cx equal to minus J R2 by omega C3 R1 minus J omega will get cancelled. Omega will get cancelled. So the rest of the term here is 1 by Cx equal to R2 by C3 R1. And finally, I'm writing here Cx equal to, I'm inversing R1 C3 by R2. It is the capacitance.